Good day, ladies and gentlemen. Thank you for letting us to present our research today at 4th International Conference on Computing, Information Science and Engineering, ICE 2024. We are the authors for this research: Mohammed Afizi, Mohammed Shukran, Kamaruzzaman Muscat, Mohammed Siddiq, Mohammed Yunus, Mohammed Naeem Abdullah, Mohammed Risal, Mohammed Isa, Mohammed Adib Khairuddin, Wan Noor Shuhada, Wan Nick Khairuddin, Nooraniza Wahid, and Mohammed Nasri Ismail are honored to present our research on innovative approaches in facial biometric security, a comprehensive study of advanced digital image clustering technique. Before we delve into the details, let us provide you with a brief overview of this research as an introduction. This research consists of 4 topics. We will start by exploring the digital images, clustering strategies and their relevance in facial biometric security. Next, we will go through on detailed analysis of characteristics and analysis of clustering methods by analysis, highlighting the distinct features, advantages, and limitations of various clustering methods. Then, we will discuss on the pivotal role played by digital images, clustering methods in content-based image retrieval. And lastly, we will emphasize on transformation of image organization and retrieval paradigm for facial images that, surpassing traditional metadata reliance. Generally, clustering techniques is used to group similar data points, including digital images. Within the context of content-based image retrieval systems, the process entails the grouping of regions or pixels based on various characteristics such as color, texture, or spatial proximity. By utilizing visual content-based methods for digital image clustering, the organization of images becomes more efficient compared to relying solely on metadata within a dataset. Digital image clustering techniques typically involve the computation of RGB data to assign images to cluster memberships. In pixel-based digital image clustering, each pixel's RGB strength is assessed to determine its value, thereby serving as a data point in the clustering process. While pixel-based clustering may exhibit inefficiencies under extreme lighting conditions, it remains a preferred technique for detecting color densities and isolating objects. This preference arises due to its simplicity and the satisfactory segmentation output it offers, making it a popular choice among researchers and developers of content-based image retrieval systems. Based on theoretical analysis specifically on pixel-based digital image clustering methods, pixel-based segmentation highlighted as a simple and popular technique. The adaptation of pixel-based digital image clustering methods will introduce an advanced methodologies and incorporating cutting-edge technique for biometric systems enhancement and evolution of facial recognition methods. Researchers have introduced several pixel-based digital image clustering methods, distinguished primarily into 2 categories: edge-based and region-based techniques. Edge-based methods analyze image content by focusing on edge detection, while region-based methods categorize images based on color regions. These 2 approaches offer distinct advantages and cater to different requirements within the realm of digital image clustering, providing researchers and practitioners with a diverse array of tools to address various clustering challenges. The centroid and cluster border are essential components in cluster analysis, shaping the understanding and delineation of clusters. The centroid symbolizes the geometric center of a cluster, positioned at the average or mean point of all data points within it. Its dynamic nature is pivotal, iteratively relocating to align with the mean of all cluster members, thereby reflecting the evolving composition of the cluster. Moreover, the cluster border, positioned at the midpoint of centroid distances, defines the spatial extent of the cluster. It serves as a boundary within which all cluster members reside, effectively determining the size and spatial distribution of the cluster. Together, the centroid and cluster border provide critical insights into the characteristics and boundaries of clusters, guiding the clustering process and facilitating interpretation of clustering results. Numerous pixel-based digital image clustering methods often fail to entirely occupy the data space with cluster areas, leaving behind a noticeable gap between cluster borders where no cluster affiliation exists. This unassigned region is commonly referred to as thresholds. Within these thresholds, outliers may emerge data points that lie outside the defined clusters. In response to the presence of outliers, certain pixel-based digital image clustering methods employ strategies to accommodate them. This may involve adjusting cluster borders to absorb outliers or creating new microclusters to encapsulate these anomalous data points. By adapting the clustering boundaries or introducing supplementary clusters, these methods strive to refine the clustering outcomes and enhance their ability to capture the full complexity of the data space. Understanding the intricacies of cluster behavior is paramount in selecting the most appropriate digital image clustering methods for a facial biometric security dataset. Pixel-based digital image clustering methods emerge as the preferred avenue for further analysis. These methods are categorized into 5 distinct categories based on VI's framework: volume, variety, and velocity. These categories namely as density-based, grid-based, hierarchical-based, model-based, and partition-based clustering algorithms. Density-based clustering algorithms strategically position centroids in dense areas, allowing clusters to expand as new objects are incorporated into a predefined maximum size. Grid-based clustering algorithms partition the data space into grid regions for organization. Hierarchical-based methods organize datasets into hierarchical tree structures, facilitating a multi-level analysis. Partition-based algorithms, on the other hand, assimilate each object to at least one cluster, effectively minimizing outliers. Among these, researchers widely favor partition-based techniques like k-means for their computational simplicity and efficiency. A comprehensive analysis was conducted to determine the digital image clustering strategies that could enhance segmentation output for facial recognition content-based image retrieval systems. This analysis took into account 3 attributes: approach, strengths, and weaknesses of each digital image clustering strategy. Upon thorough examination, it was discovered that the k-means clustering algorithm, categorized under partition-based clustering strategies, emerged as the most suitable clustering algorithm for the aim of this research. K-means offers computational simplicity, making it highly efficient for handling complex datasets commonly encountered in facial recognition tasks. One notable advantage of the k-means algorithm is its ability to operate without thresholds in the data space, effectively eliminating outliers. This attribute ensures a more robust and accurate segmentation output, crucial for the reliable identification of facial features. From the analysis and findings presented in this research, it serves as a pivotal catalyst for propelling advancements in facial biometric security, igniting inspiration for both further academic exploration and practical industry applications. Delving into practical applications and potential advancements facilitated by the methodologies employed, the aim is to not only inform but also inspire future endeavors within the field. By delving into practical applications and potential advancements facilitated by the methodologies employed, the aim is to not only inform but also inspire future endeavors within the field. In conclusion, the exploration of diverse landscape insight of digital image clustering strategies has unveiled a spectrum of clustering methods tailored for facial biometric security image processing, each presenting unique strengths and limitations. Approaches such as density-based and grid-based strategies vary in terms of accuracy and computational time considerations, whereas hierarchical-based and partition-based methods involve trade-offs concerning complexity and outlier management. Regarding the significance and contribution of the research, This study represents a significant advancement in the realm of advanced digital image clustering for facial biometric security. Its originality lies in the meticulous analysis of diverse clustering approaches, providing valuable insights into their functionalities and real-world applications. The inclusion of a summarization table further enriches the research by aiding practitioners and researchers in decision-making processes, offering a clear overview of strategy features, advantages, and limitations for informed decision-making. Before concluding our presentation, we extend our heartfelt gratitude to the National Defense University of Malaysia for their generous support through an internal grant, which made this research possible. This study was conducted in conjunction with the overarching research project titled as Improvement of Facial Biometric Security Requirements Approach Using Partition-Based Digital Image Clustering Technique. With that, we conclude our presentation. We sincerely hope that our research has shed light on the potential applications of clustering techniques in facial recognition systems. We look forward to reconnecting with you at the next edition of the International Conference on Computing, Information Science, and Engineering, ICISE. Until then, we wish you all a wonderful day ahead. Thank you.